In this video, we're going to actually look at a far more useful calculation. We're going to look at how we can convert between moles and masses. Now, in order to do this, we're going to need a molar mass. Now, from our previous work, we know that 1 mole is based on 12 grams of carbon-12. But we also know from year 10 that the relative atomic masses are compared to 12 grams of carbon-12. From this, we can actually say that 1 mole of carbon-12 has a molar mass of exactly 12 grams. We could also say, for example, that 1 mole of magnesium would have a molar mass equivalent to what is on the periodic table, which is 24.31 grams. Now, the molar mass of a substance has a symbol big M, and it looks very similar to the one that we looked at last year, which was the relative molar mass, relative molecular mass, or the relative atomic mass. And remember, they have no units because they're a comparison to carbon-12, but this one does have a unit because it is based on how many grams per mole. Now, from this simple relationship, we can actually come up with a little formula to help us calculate the number of moles, the molar mass, or the mass of a substance. And we use this formula. Now, remember back from previously, little n is equal to the number of moles. Little m is a mass, and the mass is always measured in grams. And big M is our molar mass. Now, we get that one off the periodic table. Now let's try some examples. It says calculate the number of moles of 52 grams of magnesium nitrate. Now, it's really important here that you get the correct formula, because if you get the incorrect formula, everything from now on will be wrong. So the first step is to tell your marker what you're doing. You really want your marker to be your friend. So you go the number of moles of magnesium nitrate is equal to a mass over a formula mass. Now, we don't know the number of moles, that's obviously what we're trying to find, but we do know the mass, and the mass is 52 grams. And going to our periodic table, we work out our molar mass. Now remember, we go through and we follow the formula. Magnesium weighs 24.31, add bracket, nitrogen, which is 14.01, add oxygen, which is 16 times 3, close the bracket, times it by 2, and you should find that the formula mass for magnesium nitrate is 148.33. Now we can solve, and we get 0.351 moles. Now remember, we need to answer in 3 significant figures because our question came with 1, 2, 3 significant figures. Now let's try a second example. This time we've been asked to calculate the mass of 4.75 moles of calcium chloride. Now we've been given the number of moles and we've got the formula, calcium chloride. Now remember, you must get the formula correct. If you don't get it correct, it won't be right. So once again, tell your marker what you're doing. You are finding the number of moles of calcium chloride is equal to a mass over a formula mass. Now, substitute your numbers in. So we know that we have 4.75 moles. Mass we don't know, but the formula mass or the molar mass we can calculate. So going to our periodic table, we work out that calcium is 40.08, add chlorine, which is 35.45 times 2, and you will end up with a molar mass of 110.98. Now from there we need to rearrange. So the mass is equal to 4.75 times 110.98, which comes out to 527 grams. Remember, we were given the question in 1, 2, 3 significant figures, so we must provide our answer to 3 significant figures. Now let's try our third example. We have been asked to determine or calculate the molar mass of ethanol if 1.5 grams of ethanol has a mass of 69.1 grams. Now with this particular question, you don't know the formula of ethanol. You are supposed to work out its molar mass. So let's work it out. We're going to say the number of moles of ethanol, tell your marker what you're doing, is equal to a mass over a formula mass. Now we've been given the number of moles, which is 1.5. Our mass is 69.1 and our molar mass we don't know. Now we're going to have to rearrange. So I'm going to do a little bit of cross multiplication. So big M or molar mass is equal to 69.1 divided by 1.5. And this will come out to 46.1 grams per mole. Remember, this one here is measured in 1, 2, 3 significant figures. This one has got 1, 2, 3, 4 significant figures. So our answer should be to 3 significant figures. Now it is important for you to go to the OneNote page and try the 3 practice examples so that you are ready to work in class on the worksheets.